Well, welcome to today's webinar. It's episode number 9, the concluding episode of our series on After the Crossroads, AI and Our Future. And we'll be focused today on the AI engine, design, its development, and future destiny. The network series on AI and our future has carried us across 8 different episodes, examining how artificial intelligence is transforming productivity, healthcare, education, communications, security, even governance. We began with an introduction to AI as a force reshaping human agency, and we concluded with last week on governance and how societies might regulate and direct the course of AI, which is moving at an extremely rapid rate, certainly overwhelming as we were hearing regarding governance, the capacity to regulate it. And some would like to regulate it as a threat, and some feel we got to keep it open and move as fast as it moves. AI safety researchers, however, warn that should something like AGI be created, humanity may no longer control its destiny. For the first time, we could be toppled as the dominant species in the known universe. This Mustafa Suleyman book, The Coming Wave, that's the point that he makes, is the importance of containment. The bringing together of bio and computing science may in fact be a future with bioscience. Having with CRISPR the capacity to now unravel the gene and reassemble it, and integrating it, as some feel may in fact be necessary in order to achieve AGI, is that consciousness needs to be woven into the algorithms. What the series did not probe deeply was the engineering of AI itself, that is, the machine, the infrastructure, the data centers, and the destiny of its design. Where's it going to take us? Will it reach a limit? Is it capable of taking us all the way as we imagine it? Today's webinar of panelists will explore the promise and the peril of AI's design and development. And I'll also be probing them, they're not aware of this, of whether the AI bubble is about to burst. But before we begin, let me introduce the panelists. Osmar Zain is at the University of Alberta, a well-published researcher. I've known Osmar over some time, personable, even though he may well have spent most of his life in academia. He knows how to cross the river. He knows how to get over the moat and talk to us humans. But his background is in machine learning, data mining, health informatics, and AI for sure. And he's earned multiple Lifetime Achievement Awards and served in leadership roles with ACM, SIGK, DD, as if I knew what the hell that meant. And then there's Werner Bigler, who I've known well as well. And Werner's sort of our commercialization entrepreneur. Successful, focused on market, a product leader, co-founded Verify, an Edmonton startup that we sold to Chegg in 2021. The timing was extraordinary, given where Chegg is today and where EdTech ended up after COVID. He later served as Senior Director of Project Management at Chegg, now supports Alberta's innovation ecosystem as an angel investor and mentor. He's got something to say about Canada's innovation system and the readiness in order to commercialize what Osmar and others within the academic research infrastructure of Canada bring forth. And then Bruce as well. And Bruce and his family I've known well, the Matichuk brothers, all of whom seem to have an entrepreneurial streak. He's a technology leader in AI and digital health. He's currently driving R&D at MedWatch Technologies, and his work focuses on non-invasive biosensing, intelligent health platforms, improving reasoning in transformer systems. He's a former CTO at multiple AI startups. In other words, commercialization is also in his blood and in his family, as I've mentioned earlier, and he's pursuing a PhD in applied AI for healthcare at the University of Alberta, and will graduate when Omar gives him permission. And finally, Bill Jones, no stranger to the network, and that Bill's been featured in several webinars as we discussed sovereignty and getting to yes with the US. But that's not the topic that I brought Bill forward today. He's also involved heavily in the development of the Alberta Economic Embassy, which is a next generation data center and innovation campus. And he's also, as I noted, a frequent speaker on sovereignty and Canada-US relations. So that's our panel. We've got a good audience today from Ottawa to Victoria. from Edmonton to Calgary. And someday we'll get a little smattering of US in here too. I think we may well have a New York viewer today. So I'm going to start out with the algorithmic frontier, Osmar. Behind every leap in AI, and these leaps are coming every day, are advances in scale, optimization, and alignment. These breakthroughs may point toward artificial general intelligence and possibly expose its risks. So my question to you is how do breakthroughs in scale and data and optimization and alignment, all these breakthroughs that we're hearing define the current limits of AI design? Is there a limit? Or don't we, or do we even know? And are today's agent systems pointing us toward AGI or simply exposing us to its risks? So, wax eloquent. Let's hear what you have to say, Osmar.
Well, we're hitting the limit on many fronts already. So scaling up models definitely boost performance, and this is what we believed for a long time until DeepSeek from China came out. And then we realized, oh my, there are other things we have to look at, not just scaling up. Scaling is hitting what we call this diminishing return. So it's reached a plateau where, yeah, you can add more GPUs, you can add more this and that, but what you gain is very, very, very small. So it's becoming too complex and too expensive. And it's not just expensive in terms of adding GPUs and so forth, but you need to dissipate the heat. So the cooling systems are becoming very expensive, and that requires more space as well. So I don't think scaling up further will help us. We have to look at uh, other possibilities. In terms of data, we're also hitting a limit. Um, this is due to the fact that the data that we are using online, what is accessible online, there's a lot of redundancy. So if you add more data, you don't add much. And actually, if you add more data, sometimes it may hurt. As you know, there's a lot of data today online that is not actually human. It's synthetic. It's generated by these large language models, whether it's images or articles or posts or whatever. People are using them and they're putting them online. And there's a research team that actually looked at how can we generate more data on purpose for training. So they basically took a language model, they generated a lot more data, and then they used that data, the synthetic plus what existed, to build yet another model, and then they generated more data. And then with that data, they generated another language model, and they kept on doing this. And at one point, they realized that the output, what is generated, is gibberish. And they call this the LLM dementia. So it's not helping to add more and more and more data. So there again, we hit a limit. So it's not just scaling in terms of architecture and infrastructure, but also scaling the data doesn't help. Now, the alignment, that's the thing that is very interesting, and there's still a lot to be done. The AI systems frequently lack robust reasoning and generalizable logic. So LLMs, as we know, they don't reason very well, if they reason anyways, and they don't plan very well. Even sometimes surprisingly very simple logical reasoning, they fail. So that's where we can still improve. We can improve significantly. In terms of, you also talked about agentic AI. Agentic AI is basically giving autonomy to the agent to make decisions. And often there is a misalignment as well with our own goals, the goals that the AI sets for itself, or the sub goals anyways, they may misalign. And that's also something where we can still do a lot of improvement. There's a lot of work to be done there. I think you addressed also AGI in your question. Your question is quite overloaded.
I know. It's wide open.
Yeah. We can bring up AGI again later because there's a lot to be said there. Many people think we are very close. I don't believe so. We saw it historically, so everybody remembers Deep Blue when we beat Gary Kasparov. There was a huge hype. We said that's it. We now do better than humans. Then we realized it's not a big deal. Then Watson came out in 2011 when we beat the best Ken and what's his name Jenkin in Jeopardy. And again, we said that's it. We do better than humans, and it took us years to realize that actually Watson wasn't worth that much. IBM actually killed it
Mhm.
at the end because they couldn't commercialize it as they hoped. Each time we have something, we say, okay, that's it, we reach AGI. I think AGI is more complex than we think. Our thinking and our reasoning, how we don't know how we think and how we memorize how this machine works. So it's very difficult to really. We will attain it one day, but I don't believe it's that close. Now, there's this issue with danger, the danger that comes with AGI. I'm among those who believe that actually AGI will help us. The danger is not the AI, the danger is us, the humans, how we use AI. We are misusing it because we are selfish. We are driven by profit. We are driven by power and things like that. So we're misusing the tool. We are the danger. And I'm hoping that AGI will bring us more wisdom.
Well, we've chatted about this frequently that it can go in either direction, and like fire, like the
That's
wheel,
true.
whatever technology is brought forward, it will always have some element of risk, and we just need to learn how to use it and not abuse it.
I agree that so we should not dismiss the risk. The risk is there. We should start talking about it now as we are doing before it happens, even though AGI is still far away. Uh, but we should look at the positive side as well. We should not dismiss the risk, but we should not put brakes for AGI because there are many positive outcomes as well.
Well, it certainly is moving at the speed of light. I mean, when you get 100 million users within that first period of time and now billions, our problem is not take up. I think what we're all hoping is that there isn't some crash, some cataclysmic event during the evolution of AI that somehow results in it being shut down. But I'll let Bruce pick up from here. Bruce, anything you want to add beyond what Osmar said?
Yeah. Well, Osmar and I disagree on a bunch of things. Or do they, I think like when you look at scale, that could be a big word and that could refer to a lot of different things, right? So will scale help? Absolutely, it has to help. You cannot make these things smarter without scaling, but how do they scale is the question. So most of the gains that you've seen in recent history have occurred because of the realization that the transformer mechanism, which is underlying how large language models work, current language, best thinking in large language models is this transformer mechanism. It works better when you scale it. And this was a discovery. In fact, these are emergent properties. I think a lot of people don't realize that most of the intelligence that is currently in LLMs was discovered. It wasn't designed. It was discovered. And there's still many, many, many discoveries to be made as these things scale up larger. Like, so you're thinking math, right? This is an emergent property, the ability to do logic, even, or the ability to solve logical problems, or even to do planning at any level, right? Emerged as simply as you scaled and you increase the amount of data. And it's pretty clear that these things are way, way, way more intelligent today than they were a year ago versus 2 years ago versus 3 years ago. They're vastly more intelligent. So I use it. I use large language models like with vibe coding, for example, which is a way to use large language models to write code. These things will instantaneously write vast amounts of code for me that if I were to code it myself, it would take me days, months, or years. And it writes the code instantaneously, including menus and drop downs and data and searching and everything that I want. These things already have achieved in many ways what we might call AGI, right? So you could think of it categorical AGI if you want to call it that, right? It's not AGI in all categories, but it's AGI enough. It's AGI enough that it's so useful, and you know that it's useful because billions of people are using it every day. It's used more than any other technology on the planet right now by most people in most ways, right? So where scale is needs to come in to help it to get better is what we realize, as Osmar pointed out, is that the monolithic versions of LLMs, where you just have many more layers with many more parameters, those things don't seem to. We are reaching diminishing returns on monolithic versions, but in these but and like with DeepSeek, what they showed was that with a very small, what are called these small language models versus large language models, right? Is that you can achieve equivalent results. You just train them differently. So you train them on different data sets. You train them with large language models as a teacher. There's lots of ways of doing that architecture. But what we realize is that where vast amounts of increased intelligence come when we mix LLMs. So one of the agentic architectures is what are called mixture of agents, where you have an agent is more than one LM. So that is a kind of scaling. Like if I have one agent versus two agent, well, I've doubled my parameters. These things are vastly more intelligent when you mix them. And the mixture of agents architecture basically takes a problem, it divides the problem up into a bunch of different perspectives that multiple agents look at, and then you have other agents that take that perspective and summarize it, and you get vastly increased intelligence. So when I look at this problem of scale, yes, scale helps, but scaling in the right way. And we have to, and this is already happening. And what we're seeing is every single month, these things are getting smarter and smarter and smarter because companies have a commercial incentive, a huge commercial incentive to continue to scale and to continue. This is a race. This is a worldwide race right now, and there are billions of dollars being poured in by countries, sovereign funds, investors. Everybody's racing to make these things smarter, and it is scaling. The
Okay,
problem,
we're gonna touch on that financing shortly. Osbar gave us a sober perspective. Your level of enthusiasm is infectious,
yeah,
and it seems to me that if we were to just stop
Can I,
development of AI right
can
now,
I answer? Can I answer one thing?
yeah,
Uh, we don't have to have AGI for it to be useful. I mean, I
well,
agree that we have
that's right.
millions of people using it, but it's not because it's close to AGI that they're using it. They're
Yeah,
using it because it is useful, because it improves their productivity and so forth. So AGI is something else.
a point.
Now this competition and the race that Bruce is talking about is the most dangerous thing in this whole context, because due to this race, people don't invest in containment anymore. They don't have the time to make sure that things are safe. The
mm,
competitor will reach before me, so I have to go forward, period. That's the danger. Now, in terms of scalability, so scaling, I think scaling hardware, we know we reached a plateau and we should stop doing that. In my opinion, we should focus on scaling optimization. So when Bruce is talking about different ways of training, that's exactly part of the optimization. Thinking about different ways of different architectures of within, not adding more hardware which costs more and will require more energy, more power, more cooling, more and more and more, and so forth. So we have to scale intelligently, not just blindly doing focusing on hardware.
Okay, so the investment, we've got choices to make, whether the financing goes for more algorithmic development and breakthrough many more frontiers, even though we're seeing something right now that if you didn't do any more algorithmic development, we probably have 100 years of realizing all the potential of what we've achieved in the last 3 years, much less what's going to happen over the next 30. But it isn't going to stop because
Sure.
human beings, what they are, and curiosity and knowledge and pursuit, we want to find out how far we can go. I'm going to jump right into infrastructure, though, because you've opened that up of a point that you've just made, Osmar. And one should be concerned that if everybody's out there right now developing data centers based on today's design, next year's design may be very different. We may be investing in a structure that is way too rigid and not flexible enough and not the right cost. So, Bill, you're involved in this right now. You're raising funds. You're putting a data center together. And you've got some perspectives on some of the limits right now. So I'm going to let you take on that question of what are the critical physical challenges, chips, energy, cooling, transformers, reliability, that could slow down AGI's development. Maybe it should be slowed down. So go ahead, Bill.
Yeah, the physical infrastructure is going to be the limiting thing. I mean, in Alberta, the known projects to build data centers exceeds the entire electricity grid of Alberta by 20%. And so suddenly the issue isn't the number of data centers, it's the amount of power. And that's becoming a major constraint and something I'm facing personally as well in defining data centers. Alberta has a policy, if you want to build a data center, bring your own power. So that will be probably the limiting factor for the next decade. We just can't build. And the constraint is not typically where you would think it is. It's not in the amount of power we can produce. We've got lots of natural gas. It's actually actually the delivery power. So it's getting it on the grid from where you're producing it in the middle of nowhere to where your data center is. And so we've got data centers being built in the middle of nowhere because they're closer to power, with all the constraints that brings in. You still need people to work and things like that. So yeah, the physical infrastructure is becoming the constraint. The other thoughts here, I mean, both the previous speakers, utterly brilliant. Really love the dance between the two. Scalability, absolutely. Scalability does have a top side. You can double the computing power and get 10% more benefit. Yet at the same time, it is really, I think, the use of the tool. People tend to be looking at AI as replacing our order takers or answering the phone or filling in an email. My personal experience of it, really pressing the model to its limit, is really empowering the transition between knowledge and wisdom, where I have no real product. I've not replaced a person, but I've used the tool to force multiply my own efforts by anywhere from 20 to 100 times, and not generated a program, not replaced a human, not answered a telephone, but the intelligence of transferring the knowledge out there to me in a concise way that I can understand to be able to make the project go forward, I think is the real power, where we transition from knowledge into wisdom. And the wisdom still is 100% owned by the human. All AI is providing a nicely condensed knowledge base, filtering out the nonsense to what is really key and vital, has been transforming to me, and complete surprise in its ability to do that. So I think we tend to focus on, I see a comment in the chat, What about the jobs it's replacing? I don't think it's replacing any jobs. I think really, yes, a lot of companies are looking at doing that. You know, I can cut 100 people and put one agent in and do the job. I think that's the false economy. I think the real power is going to be up the higher level, better decision making, better information, better filtered information, and then the key decision makers making a conscious decision based on that.
Well, that's
Thank you.
the drift of the organization of recognizing the value at the top, but it's the people at the bottom that seems to be the order takers, where the processes are at this stage are rather simple, very transactional, and very repetitive, where AI steps in. Werner, from a commercialization point of view, and I'm jumping around given the richness of this panel. One of the impediments to the development is commercialization. I mean, Osmar and others of his ilk are finding ways to open up a new future. Capital has got to find its way there, but it's going to take money, management, moxie, manpower, and
can I just backtrack for a second? But Moxie always follows money, just so you know, from an entrepreneur perspective. Just to clarify a comment that was raised. So OpenAI recently declared that their run rate for the year is going to be $13 billion in revenue. If you work those numbers backwards, they have 50 million paid subscribers. Not 100 million, not 2 million, not 2 billion. 50 million monthly paid subscribers paying $20 a month for their services. Okay, just to put that in perspective. The other thought I want to add to Bill's comment, and I just want to see if I can share a slide here. So basically, recently you probably all heard OpenAI signed a contract with Oracle for providing basically a $300 billion contract for providing multiple gigawatts of data centers, basically what they call their Stargate initiative. OpenAI in January this year put out a 7-page, I'll get this right, a 7-page RFI to the industry to provide data centers starting in 2007 for 5 years. They're looking for 10 gigawatts of facility and plant space. And they have 5 sites already identified. This one here, Oracle has a site, I think it's in Texas, that's Simco. Simco is a data center builder. Oracle is working with them to provide it. This center needs 1 gigawatt of energy. And I was quite surprised. I did a lot of research the other couple of days on it. How they're providing it, GE, Vernova is an ex-GE company. What they're basically doing is taking aeroderivative gas turbines, so the same jet engines that were used to power the 747 and Airbus A300. They're shipping 29 of these. Each of these produce about 34 megawatts of power. They're shipping 29 of these to someplace in Texas for this Simco data center that will eventually require 1 gigawatt of energy. These Alum 2500 Express, I'm thinking you may hear that word a lot these days, but this Alum 2500 Express, they could be stood up in as little as 2 weeks. So if you look at Oracle, you know, there's rumors that they're going to do small, medium nuclear reactors, small reactors. Those take years to permit, although there's rumors they've identified sites for 3 of them. They're going to take years to get rumored, years to get societal blessing and all that. When GE is in the same boat, there's 2 other companies, Mitsubishi out of Japan, and I think there's a German company as well that can provide these. So the whole question about energy turned around quickly to a data center, I think has been answered. But this raises the question about, you know, how do you do sound abatement? Because you have 30 of these things making noise. There's already issues with Musk has a plant, I think, he has a data center somewhere in the south that already is causing issues with sound and noise and pollution. But the whole question about how you turn these plants up quickly, I think GE has answered it.
So this is a dedicated source of energy for that particular utility. You don't need to worry about.
They're parked, Perry. They're parked. There's a picture of Musk's plant. He's got his turbines like parked right beside them. There's no there's no going on the network. They're just wired directly into the plant. Yeah.
So Bill,
Crazy.
you got another slide to show, Werner, but I want to ask Bill. Bill, any comments? Are you aware?
Absolutely. There's the actual energy production is not the problem. The problem is getting it to where you need the data, where you need the energy, the distribution and the network necessary. Certainly we can, I mean, Mr. Wonderful wants to put a multi-billion-dollar data center in middle Grand Prairie in the middle of a field in nowhere, because that's where the natural gas is, and you can certainly provide these turbines to provide it. But who the heck is going to go out to the middle Grand Prairie to run a multi-gigawatt gigawatt data center? You have to be in the middle of nowhere. You've got to move your data center to where you've got natural gas. And so it's easy for machines to be in the middle of nowhere. It's very hard for people to be in the middle of nowhere. And we still need people to run these things. So that's the real challenge. We're missing access to natural gas. So you've got to go to a natural gas field. Well, they're not really around population centers. So we've got this mismatch. Yes, we can create as much power as you want, certainly, but people versus data center location versus gas fields, we've got this conflict where how do we make them come together? And that's the real struggle today. So absolutely, we can. Those engines are wonderful. I'm looking at them myself for another project. But that project is not in Edmonton. My data center is in Edmonton. So that offers a whole different set of constraints in trying to get power to that data center.
So any discussion on data centers, there's a recipe and it's more than a single ingredient. So Werner, you've got a second slide. Another point you want to make?
No, I wanted to transition to your question
on commercialization.
Your question on commercialization. So I'm just going to share this slide as well. Been doing a lot of research. Okay, can everyone see this slide?
Coming up, there it is.
I should be able to. What can I go in presentation mode? I think it'll screw it up, hey?
We're happy with what we see there.
So okay, very good.
Fine.
So
flip to your main screen and really mess up. Yep. So go ahead.
Yeah. So basically, lots to talk about, and Perry is a big proponent of this. Is just where Canadian entrepreneurs, not the technology, but the entrepreneurs, and innovating and taking this technology to market. So here's 5 of the largest Canadian AI startups. You'll notice the majority of them are in Toronto, but these are the top 5 companies. Bruce and I'm sure Osmar, you've heard of these. But Cohere and ADA are the two unicorns. Cohere is focus on the enterprise, making enterprise secure frontier models. ADA is introducing AI to customer service through voice and written email automation. Both of these are both kind of quiet giants. Interesting enough, ADA only raised money in the boom year of 2021, where 2 people and a dog could raise $10 million on the slide deck. So goes a rumor, with money being pretty available. But Cohere and ADA are up there. The other 3 are probably not familiar to a lot of people. MindBridge, a company that's using AI and auditing and internal controls. It's a finance vertical fix. And then Deep Genomics out of Toronto. Again, it's applying AI to the whole genome race. The one that's interesting that I think many people don't believe, but there's a company in Toronto called Wabi. Wabi is focused on building an autonomous stack for driverless, first of all, commercial vehicles. They have trucks on the road today, obviously driven by the AI, but partnered with the human being. They are working with Volvo Trucking, and the last report I had from them was that they were hoping to get this year a license to actually have their trucks run in Canada in very certain fashions without a driver. So here in Toronto, or here in Canada, we have Wabi that's, you could say is contending with the Ubers and the Googles of the world to produce driverless cars, which is very interesting. So they last raised $200 million 2024. So they are probably well over $1 billion in valuation. But 5 interesting companies, large companies in Canada. I myself, as Perry alluded to, I've been an active angel investor since 2021, invested in probably 7 companies to date, half of which are AI application companies. That is, they don't obviously have a frontier LLM model, but they go ahead and they build an AI application sitting on top of an LLM for vertical application. There's a lot of those companies around. The space is getting pretty hot and heavy. But Canada, other than Cohere, does not have a frontier LLM development shop.
Well, we spent some time, and Osmar, all of you were aware of some of the work we did in the Alberta Council of Technologies. And the challenge that we saw Alberta had is it's young. And the networks necessary in order to expedite the flow of knowledge and commercialize it really had nothing to do with the availability of money. Not to say money isn't important, but it had to do with we didn't have the mature networks, and many of our institutions were relatively young, taking care of their own development, and not necessarily part of a collaborative economy. Alberta suffers accordingly. It is a young province, and we don't have a lot of old money. We don't have
that I don't buy that. I mean, like you look at DeepSeek, for example. DeepSeek is just like a few people in China, right? So and they did it and they built it and they got it working.
How did they get it out into the world at large?
You on the internet, everything is available instantaneously.
I'm not quite so sure that make it and they will come. But anyway,
Well,
that's
that's what DeepSeek did.
You'll have to come up with another explanation then on why Alberta and our research institutions are having difficulty getting their products commercialized.
They
And whether or not they're
focus
really,
on the wrong things. They focus on things that are not commercially useful.
well, AI is very commercially useful, and
Well, it is.
I hope Amy is the bridge over the river of Saskatchewan. Okay, next topic.
So,
Ethics and
so
regulation.
sorry, Perry, I wanted to add another ingredient in the soup.
Please. Okay.
So in addition to power and infrastructure like GPUs and so forth, like Bruce mentioned, having different LLMs working together. For that to happen, you have to have very good network bandwidth and low latency. So to be able to interconnect these a distributed training, for example, system, to make it efficient, you have to have a good bandwidth. So the infrastructure, the network infrastructure is hugely important. We should not forget that, especially if you want to put the data centers far away. If you have a very thin kind of connection to it, it's useless.
Yeah.
Gotcha. Okay. Further, by the way, Bill, you brought to my attention the shortage on a global scale of transformers.
Yeah, that's the key bottleneck of getting distributed power to where it's produced to where we need it is transformers. You got a 5 to 8 year backlog, and it's intractable right now, especially with the Ukraine war. Yeah, everybody's blowing up everybody's transformers over there. So a lot of the product is going that way to keep things going, which is draining us over here. And it really comes down to, ironically, the manufacturing of grain-oriented electrical steel, which is controlled by only 3 companies in the world, and they own the IP, and they don't want to build any more plants. So it's really locked up down to the very core component, and that's getting our GOES steel produced in sufficient quantities to actually make the transformers. So I think that's the key is we take a kind of a superficial view over the constraints of the expansion of data centers and AI, that, hey, if we build more of this, we'll have more power. Well, data centers need power. Okay, well, let's get more power. Well, you need to produce it. Okay, we can produce it. Okay, well, you need to get it to it. Oh, we need transformers, and suddenly you hit a wall.
Is that a stock tip?
Sorry?
Is that a stock tip?
It sure
Well,
is.
I wish it was. I
I got a garage full of transformers. You want some?
but yeah, certainly you come down to something that's really fundamental. It's like you know, great, we can make big cities, but if you can't have a highway to the city or roadways or railway, you can have a city in the middle of nowhere and nothing gets to it. And I think that's what we're running into when we're doing these infrastructure plays.
Look, this is very characteristics of any emerging technology. You get that initial phase of hype about all of the possibilities, all the optimism, the capital is flowing, and then you realize the infrastructure that needs to be put in place is going to take time. And then it slows down and the curve begins to rise again. And I think we're in that very early phase. I've never seen money flow at the rate that it's flowing. E-commerce certainly was a period. I don't think this is quite the same, but the bottlenecks around infrastructure are going to be serious. You need data centers, and they're coming on in huge volumes with enormous amounts of capital. And if transformers, by way of example, is one of the gaps, you're not going to solve that with a blink of an eye unless someone comes in with some solution that doesn't require transformers, and good luck there. Okay, in the interest of time, I'm going to jump into ethics and regulation. Guardrails for AI are often set after deployment. The debate is whether responsibility for ethics and safety should begin earlier at the very stage of design itself, on an assumption that this will continue to evolve and the risks will continue to grow. So the question is, should regulation begin at the design stage rather than after deployment? Who sets the guardrails? Anybody want to jump in on this one? You must
Well,
worry about guardrails, Osmar. I mean, there you are putting something out into the world at large. Some people feel should be contained. Do you care?
I mean, yeah. No, I care definitely, but and it has to be done at design time. Waiting until deployment, that means, well, the harm can propagate widely before you can mitigate it. So you definitely need to think about it ahead of time, and you'll miss things, and you'll have to also put some nets at deployment as well. I mean, there are many things that we can foresee, and there are many things that we cannot foresee. So you need to start at design time, and don't take it for granted. Also continue to catch things that may happen at deployment. Now, who is the decider? Also, we should not wait for the regulations to happen, because regulations will take time. And if we design and start deploying, and then the regulations limit what we can do, we have to go back to the design and start over, and that will cost us more. I think we should think about what the limits should be, and put them in the design early on, and hopefully will align with the regulations. But the regulations will take time.
That calls for collaboration among the designers. Are you optimistic that the corporations of this world that are investing in these technologies are prepared to forego being a leader and just jumping on?
It should be multi-stakeholder anyways. So industry developers, the civil society, the experts, the lawyers, everybody should be involved. It's not a one person working in a silo that will decide.
We have seen that, for example, in the automotive industry, where standards were established and certainly safety measures by industry itself emerged. Bruce, you want to add anything there?
Well, so this is the number one limiting factor of growth in AI. Actually, these things are so smart, they're so intelligent, but the more intelligent you are, the more crazy you are, right? And this is the problem with LLMs, is that they're both intelligent and they're crazy at the same time. And they can come up with all kinds of crazy ideas and crazy perspectives. And so you have to have guardrails. So one way, but there's huge commercial incentive for companies to actually build guardrail systems because, if you're, so if your LLM, coaches somebody to commit suicide, for example, well, that could be really, really bad. And in fact, this has happened, and the commercial impact could be catastrophic, for the companies that are, having these building these systems. And so there's massive amount of incentives. Interestingly enough, you can build guardrails by hand coding. The problem is that you just cannot write all the code. It's impossible because there's too many scenarios. So the only way around this problem is machine learning, based guardrails, but then you have to have humans in the loop to actually facilitate the training. And so we talked about, what are the jobs? A lot of jobs are going to go away. With AI, like you look at the legal field, for example, it used to take 20 lawyers to, litigate a case. Well, now you use machine-based reasoning systems to reason about all those things. And so what do you use the lawyers for? You use them to do higher level thinking. And one of the kinds of higher level thinking that you're going to employ people to do is to help you train models to do specific things like guardrail reasoning.
Yeah, and
Well,
I absolutely agree with that. But let's take a look at history, Perry. We developed cars and highways with no rules, and the rules came after it, after
Yeah.
people started running into each other. We developed industry and built industrialization, and then after that, we built rules about pollution and its effects of building. Everything follows after the development, and I can't see AI doing anything different. It will expose concerns, and then the rules will happen, and we will have to backfill and back code or whatever that is, back train to repair those exposures. I don't think you can find an exposure before it's revealed. I think that's a quest that goes far into the unknown, that we don't know the unintended consequences of our actions until they become consequences.
Yeah.
I've heard some of the Sam Altman and others, Eric Schmidt, talk about risk. They're not afraid to talk about risk. They recognize that their entire industries and the capitalist flowing is potentially at risk if industry itself doesn't take a leadership role in containment, either containment or regulation. So the automobile industry did in fact set standards internally with collaboration between manufacturers about certain standards because they all needed to work toward common ends. So there are many elements in the design of an engine and the design of a car which are self-regulated by industry itself. I think of two things. I think one, can a profession emerge that says we will self-regulate as a profession and ensure that those that know how to do the coding or know how to do the LLMs development will in fact abide by a certain set of standards in order to retain their professional standard. That's manpower regulation.
Yeah, I think that's exactly what will happen. But
Yeah.
I think the risk and the exposure will appear first,
Okay.
and then the regulations and the self-regulation of industry.
Yeah.
There are
So
those that does not come until pain happens. Go ahead, Osmar.
no, there's a difference between the automobile industry and what we're dealing with right now because it's online. So for regulations to be effective, in addition to standards and criteria for testing and all that stuff, you need enforcement.
Yeah.
So you can enforce these regulations when it comes to a car because they're running on my roads here. I have control over that. But when it's online, how do you enforce the regulations? It can be anywhere in the world. And that's not easy to deal with. It's tricky.
Well, the genie's out of the bottle, and the only place that I know in the world that has recently attempted to contain the development is the Taliban in Afghanistan that shut down the internet.
Yeah.
A moment of that nature. I mean, we say that in just tongue in cheek, but a moment or an event of that nature may become very sobering.
Yeah.
In fact, some disaster that's byproduct, the airline system collapses, or AI becomes rogue and does something in the health industry. Something of that nature we hope does not happen.
No.
Well, the EU
But
is
shouldn't have
is
Apple
attempting to
Force.
bring in these regulations right now, right? So they've got that regulatory frameworks around AI that we don't even have here, and
We have the bill C27 that is still, well,
Sure.
it has been tabled, but it's not
But I
enforced
mean,
yet. Yeah.
we
Hasn't
are
been voted.
about the invention of the wheel that everybody has access to. This is an open source future. This is a very complex question
well,
because
yeah,
with the internet as the highway that everyone has access to and the ease with which this product can be used, we're already in that space. Like this is not about the future. This is about now. When you see what's
Yeah.
happening with young men filming relationships with AI, and what's happening in terms of people using it as tools, as the internet itself, and social media. So we're in it.
mhm.
The chaos that we're experiencing may well be a byproduct of the rate at which this technology is entering into society. As Randall would say, we neither our organizations nor our people are able to handle.
Yeah, Perry, just to backtrack for a sec. So yeah, we're in the wild west of things, right? So OpenAI just launched, GPT-3, when was it? 2023, Bruce,
Yeah.
2 years ago. So we're still in the very much in the wild west. But what you have happening is a massive FOMO, fear of missing out with these large language models. So everyone's racing to build infrastructure, racing to purchase GPUs, and to get ahead of everyone else. So you're not going to have regulation in the next year or two coming from any external body. I do agree with whoever said this, that when things settle down, it's going to be the industry itself. And it's happening today. If you watch it, every now and then there's an error from Grok that comes up. There was one last night, there was a model that OpenAI put out that took Sam Altman and put him in a different position, and so that was fixed, right? You're having the people, the users, the millions of them, regulate the industry, right?
Yeah.
Something happens, things get fixed right away, right? Grok apparently went anti-Semitic a few months ago. That was fixed, right? So I think you're going to have the users police it, and I think you're going to have the CEOs make sure over time that they have to produce a good product that doesn't hallucinate, that doesn't go schizo and start coming out in a mode that's not friendly with people. So I think that's already happened, but I think it's going to take time. In terms of government regulation, whenever it comes out, it's going to be 2 or 3 years behind in this space, if it could even regulate. I think you're going to have the industry, I think Bill mentioned it, you're going to have the industry owners, the CEOs, come to a association, and they're going to agree upon what's acceptable and what's not behavior. In the interim, it's going to be the own CEOs just fixing their application to make sure it doesn't go off the deep end, which is happening today. So there is owner regulation happening today with large language models and AI derivatives. So things are being, and because there's so many millions of users, I think things are in check pretty promptly. Is my
And
opinion.
we're already seeing that. For example, if you went to AI and said, help me build a nuclear bomb in my basement, it will chat with you, but it will lead you astray purposely. They put those guardrails in, or tell me what stocks I need to buy to make a lot of money. It will not do that because that risks
Yeah.
the
People try to get it.
advisor, and that creates legal things. So they've already built guardrails inside, even though you might not see them.
Yeah.
They tend to be more misdirected. They're not overt saying, I can't do that. It actually leads you down the wrong path.
There,
It's
there are
kind of
many ways of jailbreaking these guardrails. So
right.
so there are many ways of doing that. Like, for example, you ask a chatbot, how do I make a poison with these chemicals? It'll tell you, no, I'm not in a position to tell you that, or whatever. But if you say, oh, I have kids at home and I have these chemicals in my house, which ones I shouldn't mix so that it becomes a poison or whatever, it'll tell you. Or, for example, you tell it, oh, you promised to help me in my chemistry exam. Can you tell me what is the answer to this question? It'll tell you. So there's a way to fool the chatbot regardless of these guardrails. It's not as easy. And just opening up and closing the parentheses.
Yeah.
My takeaway from this discussion echoes the sentiment that was raised last week, and that is the geopolitical environment between nations is such that it is very unlikely that you will get collaboration between nations that are now competing to be number one. But what we hope for is that the industry itself will self-regulate in their interests of profit. In the interest of not having the chaos or not having the collapse or not having the danger. And the thing that Osmar has raised will be addressed in future coding. So the industry does appear to be responsive, as
Yeah,
Osmar says the industry is well
My-
aware
my-
of some of the abuses, and these need to be fixed. Okay, last question. Werner, I'm going to throw
yeah.
this one at you. Yeah. Competition, sovereignty, geopolitical rivalry, as I noted, are shaping the race to design and deploy increasingly powerful AI and AGI systems. But we're here in Canada. At some point in time, I need to think about what about us? What about our future? So we must decide our place in this contest as a nation and as players in Canada. Describe the AI startup scene in Canada. How will Canada compete in the global AI race?
Okay, so I'm going to limit this to my Ken, and that's based upon my experience in Alberta and maybe Saskatchewan and BC. But I think, as I mentioned earlier, the just given the lack of large VCs here and not people writing billion-dollar checks, I think the focus in Canada is going to continue on building AI applications that sit on top of or use an existing LLM, or maybe take an LLM and fine tune it for a particular use. You're seeing lots of that. I think that's going to be the focus, not on infrastructure building large language models. I think outside of China and I think maybe France, Mistral, there's not many countries in the world other than the top three that actually have built large language models. So I think we're going to follow the path of just building applications for a particular business vertical using AI, as I showed you for my list of 5 companies, and go from there. I think the one roadblock we have in Canada is that we have 5% of the VCs that the US has. So for us to do a startup and raise tens of millions of dollars for a startup to build an AI application is probably going to be the throttle point in Canada, unlike down south.
Okay. Well, we're into wrap-up mode. I do feel the need to bring in the audience that has been having chats off on the side extensively. Is there anyone that wants to pose a question to any one of our panelists or make a comment at this point? And you all know I'm going to point to you if you don't raise your hand with your own initiative. Randall, you've made some points off there on the side. Any point or comment you want to make of what you've heard today?
Well, from one of our other sessions, somebody mentioned fractal intelligence and the work being done in Montreal on that. And I'm wondering if that might be a way to reduce the problems of scaling in AI. It may reduce a lot of the redundancy in the data and the slop, if you want to call it that. Is anybody able to address that question?
I have no idea what that is.
Me neither. I don't know about fractal AI. However, I know that many research centers are working on AI and quantum computing.
Oh, yeah.
So quantum computing is still in its infancy as well. It's very expensive to build these quantum computers, and you need a very cool kind of environment. So it's very, very expensive in terms of energy as well. But people are working on ways to do machine learning using a quantum computer. The day the quantum computer is ready, we can implement these, and that will create something completely different. Completely different from what we have with the language models today.
Yeah, when we start bringing technologies together, whether it be bioscience or computing, quantum, the merging of technologies, you're getting to singularity and more. Peter, you've got a view as it relates to regulation.
Yes, I have a comment, a question, Perry, that I posed earlier in the chat, because there was a lot of discussion about LLMs generating code. And I gave a talk to about 60 business executives last week who all have responsibility for product management. And so they were managing well over several $billion worth of product development. And we were talking about AI, of course, about 60% of the people in the room were actually using AI in their products. And I was asking them about the problem that has recently arisen about low-level programmers, as in the entry level, now being dismissed by many companies because the large language models are generating the code. Well, it turns out that a lot of the code that's being generated is now requiring higher level programmers in the existing companies that have let people go to fix the code. And so the productivity of coders is actually going down. I'm just wondering if any of the panelists have any views on this problem right now.
Bruce, you've
I
got to
can-
answer because you're of the view that that's not the case. Go ahead, Bruce.
Well,
can
it's
go
the
ahead.
way it's how you use it, right? I mean, I don't think that you'd want to have commercial code, but I wouldn't get a bunch of junior coders to write commercial code anyways. That's not how it works in big companies with coders.
Okay,
So
so answer Peter is to hire Bruce. Osmar, you have anything to add there?
Well, there is evidence indeed that productivity goes down by 16% or something like that. I forgot the numbers. I read the paper a while ago, but there is evidence that indeed it's not helping in the long run, and you need to train people to actually take advantage of the output of the LLM. You don't take it like that blindly and use it. We are learning how to include the LLM as a partner in coding. We're still in the beginning,
So,
Yeah.
so
but
Perry, let me,
currently it's not helping in the long run.
Werner, you've hired coders.
Yeah, let me bring some practical research experience. So I had a barbecue the other day. I had my key developers, very young, very very good millennials, super programmers, over for a barbecue, and I asked them afterwards, are they using AI? Let me know if you're using AI and how are you using it. So all of them said they use it very guardedly, which surprised me. They use it for certain tasks, but they all said if I leave it alone, like for small, easy routines, it's great. And they use it in a consultative mode. How do I approach this problem? Give me some thoughts on how I approach this code, and then they iterate with that, and then they write it themselves.
Yeah.
Don't forget, like coders are like artists and writers. They have a certain style of how they code, and that style is unique to them, and that's how they look at their code. So they all said that. They never said to me that they'll ever have it do large chunks of code because they have to go through it and they have to review it. And doing large chunks of code for your own little app you put on the App Store is one thing, but doing enterprise level code that has to be very robust is a whole nother thing. And they all dismayed it and said they'll do it only for small jobs and never let it run and create enterprise level code because they have to go through every line themselves and make sure it's correct. So
So
I think
Osmar's sense, and yeah, you hear these, and sorry, Bruce, you hear these companies like Lovable out of the UK, millions of people creating apps. Well, creating apps is one thing for yourself, but creating enterprise level code that needs to be used by millions of users, that's a different space. And so the reality, what I discovered was they use it very sporadically and very in very unique use cases, but never let it run and create a million lines of code.
So
the thing about there's many different kinds of coding. There's GUI coding versus constraint coding versus hardcore database coding. Like coding is this broad field, and LLMs aren't equally good at all the different areas, and so that's the one thing. And in the areas that it's very good at, it's very, very good. And I would not want, if I had hired a developer, and I hire lots of developers, and I hired them and they weren't using AI to generate certain kinds of code, they would get fired. Very much like hiring a person today that doesn't know how to use Google. It's like, what on earth are you talking about? You can't use Google, you're fired. And this is what's happening with coding.
So,
Like people have to use it in order to be productive at all. But what are they using it for? It turns out LLMs are not particularly good at large, complex architecture. They can't do the architecture. Now that's changing because every single day they're getting better and better and better. And the size of code that they can actually implement is growing as we solve architectural problems using AI. But today it's very much, limited to certain areas.
Okay, so the answer to your question, Peter, your point is it's quite situational. The answer is it depends on what you're using it for. And in the corporate sector, McKinsey, I think, released a number of guidelines for corporations. Do your business analysis and your flow charts first. Don't design an AI and then find out whether it works or not. Spend a lot of time at the front end, and a lot of corporations in a rush to success are probably getting it wrong. Yogi, you've got a point you want to make.
Yes, so not surprisingly, this whole conversation has been dominated by large language models. However, I'm beginning to think that small language models may have a huge place in the future of business because most of the business applications don't require a huge domain of data. They require a smaller domain of data, and they require high accuracy, meaning curation of the data, and they require a lot of depth of understanding of specific disciplines or subdisciplines. And LLMs often can't demonstrate that for a variety of reasons. So I'm wondering whether there's any comment on my observation or whether you agree or disagree.
Well, does that touch on the application for SMEs, for example, small and medium-sized businesses, and the development of chatbots for customer service integration? I mean, that seems to be a relatively simple undertaking. Anyone want to help?
Yeah.
Help
Well, let me just say that, yes, small language models are trained differently than large language models. They're trained on very constrained data sets. The problem is the ability of the large language model to reason is strictly based on the exposure that it has to problems. And the limitation you find with smaller language models is that you don't have all types of reasoning. And so if the reasoning that it is required to do is contained within the data sets that you train it on, then it'll be fine. But the reason why large language models are more intelligent in certain contexts is because they're trained on many more kinds of reasoning problems. But you're right, small language models for specific limitation applications are more effective than large language models, frankly.
Jeff or Peter, are you bringing a new point, or do you want to finish that conversation?
Yeah, adding to it, I hope. Yes, I think that what Yogi was mentioning about the smaller language models is what we really are talking about as AI agents. And I think we'll see a lot of AI agents that'll be rather specialized in different parts of a business activity, and that ultimately we're going to see these AI agents collaborate in the form of some kind of a swarm, if you like. Although right now that kind of activity is very weak in terms of collaboration. In fact, Carnegie Mellon University did an experiment this past year where they created a number of AI agents in a synthetic company. So it was agents that were doing the different functions of a typical company, and the agents couldn't agree with each other. So the system was actually, early stage of how to create a collaboration was clearly not working with the swarming of these AI agents. But I think that is a very major development area, and will be a lot of SMEs that will fill that gap.
Okay, got it. Jeff Kramer.
So just an addition here. Sure. Large language models are so large that you can't fit them in a small computer that an SME has. Yeah. So you have no choice but to use the large language model that is on the cloud. But sometimes you don't want to do that for privacy reasons or whatever. So there are techniques to take a large language model and distill it. We call it knowledge distillation. You distill it in a smaller language model. So the large language model becomes the teacher, and the small language model is the learner, the student, and there are techniques to take the essential knowledge and distill it in a smaller one that can run on a smaller server for an SME. So the technology exists. It's not perfect yet, but people are working on that.
That's marvelous. Jeff.
Yeah, so I have heard tonight that the constraints are connectivity, infrastructure, electricity, getting power to the systems, constraints on people being able to work in the location where the data center is going to be worked. And I think that what we're seeing in the near future is all of those things will be gone if you look at, for instance, in the Arctic. Iqaluit is supposed to have fiber optic cable by 2031. You can remotely operate robots with telepresence. I mean, they're doing that with operations right now around the world. So if you can get a human-formed robot, anything that you can do in person, you should be able to do with the robot. In the Arctic, the land is less expensive. And the biggest thing is the heat. So Omar was mentioning that heat is a major constraint. Well, in the Arctic, you can actually turn that waste heat into power. And I can talk to people about that afterwards if you're not familiar with what I've written. So if we do that, Eric Schmidt says that the only constraint on, or the largest constraint on AI is not chips, it's not money, it's electricity. So if we can produce as much electricity as possible, then that's problem solved. So I think Canada's got a great future of building data centers in the Arctic.
Yeah. Bill, I know Bill is just itching to comment. Go ahead.
Oh, that's absolutely right. Data centers and environmental cooling, yeah, that there is some efficiency in there, but you always have to build for the worst, hottest day, which means that you could work in the desert as equally as you can do in the Arctic. Yes, wintertime makes it a little bit more efficient, but you're absolutely right. Electricity is the issue, and we run into two really difficult things. One, physical transformers, and two, government policy. Government is trying to stop our production of energy, and for crazy reasons I won't get into. But the irony of the build out of data centers in Canada is not that we can't build them, is that we run into environmental regulations that prevent us from producing the necessary power for them. And come on, guys, we got to vote better or start advocating, whatever it takes. But that's it. It all comes down to a matter of a human decision that really blocks our ability to build more data centers.
So yeah, I'd like to respond to that. So first of all, in the desert, you don't have access to water. In Alberta, we have lots of water. In the Arctic, we have lots of water. So that is a non-issue as far as I'm concerned for cooling. And then the other thing is that the power generation, you were talking about having to connect to the existing network and stuff. None of the communities in the Arctic are connected to a wide area grid. They are all independent power communities. So you don't have that constraint up there.
Yeah, absolutely. There's lots of solutions. One, water nowadays in the more advanced technologies is not an issue. I build data centers in the middle of the desert. We just use adiabatic cooling and other technologies to be able to deal with the heat. And nighttime is really nice. So water, we're trying to reduce the water usage in data centers. There's no point in consuming our drinking water for cooling a computer. And yes, technology will always improve to make things better and more efficient. The real challenge is who wants a data center in the middle of nowhere? And yes, we can use robots, but maybe, as you said, 2030, 2040, I'm going to be retired way beyond then. And that's not my concern today. My concern today is build them today. We do have a time constraint of competing with the world right now. 2040, great, we're going to have data centers in the Arctic. What are the Chinese going to have? The Americans, the Europeans? If we're waiting to 2030, 2040 to build our wonderful data centers, we're going to be 30 years behind.
Okay, we're into wrap up. I have one question. I'm going to pose it to Osmar because it relates to a sort of an esoteric moment of bringing biosciences into the game. Osmar, is there any discussion that you're aware of where we're looking at bridging whether consciousness is critical in order to achieve the ultimate ends of AI? Is there any discussion going on campus between computing sciences and, say, those in the biosciences?
About consciousness? No, I'm not aware of that.
So put the consciousness aside, looking at bioscience and computing.
Well, we have discussions, but not in the context of using bio in the computing, but using computing as
Right.
And bioscience as an application for computing.
Yeah.
Yes, there are many collaborations for that, but
Yeah,
not using bio for computing.
Yeah, that's where I think most of us are familiar with an attempt to replicate what the brain does through neural networks and computing science, but
So there is work. I'm aware of a work at ETH and Imperial College,
Yeah.
where they have used rat brain cells,
Yeah.
to manage a robot. So
Yeah.
the robot was told to turn left, right, or go forward or stop and so forth using rat brains. A few cells from rat brains. I know that exists.
Well, we're getting into my master's degree, so I'll leave that aside. But I want to now call it a day. I am thrilled, Osmar, that you had the time and the interest to join us today, and I hope I can call on
You're
you
welcome.
again in the future. Bruce, good luck with your career. Good luck with your degree. And I thank you as well for joining us today. I know Werner had to take off, but Werner has a lot to offer when it comes to the topics of commercialization and his familiarity with the innovation ecosystem in Alberta and Canada at large, hands-on. And Bill, of course, Bill, I wish you every luck with your center, your data center, and with the Alberta Embassy that you are involved in developing. So I thank our panelists and I thank the audience for joining us and staying.